All right, let's dive in. Every single day, we're all sending sensitive information across this massive public thing we call the internet. But have you ever stopped to wonder how it stays private? Today, we're going to pull back the curtain on the hidden infrastructure that keeps our data safe. So, yeah, let's start building our first digital tunnel.
And really, it all comes down to this one simple question. Just think about it for a second. The internet is basically a giant public highway system, right? So if you need to move something valuable and you don't want anyone looking, you can't just drive it down the main road. No way. You'd need your own private, secure path. But how on earth do you build one of those on a highway that belongs to literally everyone?
Well, the answer is you create what's called a private tunnel. And the blueprint for a whole lot of these tunnels is a protocol called L2TP. So let's break down what that actually means. At its heart, L2TP, or Layer 2 Tunneling Protocol, is pretty much what it sounds like. It's a set of rules for building a virtual tunnel. It basically carves out a private passageway just for your data, letting it cruise securely right through the middle of the public internet. You know, a really great way to picture this is to imagine a diplomatic pouch. You can send it through the regular mail, but nobody, and I mean nobody, is allowed to open it. It travels right alongside all the other letters and packages, but it stays completely private and totally secure. While L2TP does the exact same thing, but for your data. Okay, so how is this digital diplomatic pouch actually put together? It's all about this clever process we can call a double envelope system. And trust me, it's way simpler than it sounds. Here's the breakdown. It all starts with your letter. That's just your original chunk of data. Then, that letter gets sealed in an inner envelope using something called point-to-point protocol, or PPP. You can think of this as just getting the letter ready for a special kind of delivery. And finally, that sealed envelope gets placed inside a second outer envelope. This one is the LTTP layer, and it's the final packaging that creates the tunnel itself. So once it's all packaged up, this double-wrapped packet is handed off to a delivery truck, which is just the standard internet protocol. And it travels across the public roads of the internet. To everyone else, it looks just like any other piece of traffic. Its real contents and its final destination are completely hidden inside. Okay, this all sounds great in theory, but where do these digital tunnels actually pop up in the real world? Well, you might be surprised. You've probably used them a lot more often than you think. The two biggest use cases are for remote access and site-to-site connections. For remote access, think about an employee working from home. L2TP gives them something like a special hotel keycard, granting them secure access to the company's private network. For site-to-site, imagine a company with offices in, say, New York and London. L2TP builds them a private subway line directly connecting their two networks, keeping all that company chatter completely off the public streets. But it doesn't stop there. Internet service providers, or ISPs, often use it like an armored car service to securely deliver internet access right to your house. And it can even act as a kind of universal translator, helping older, legacy network gear talk to modern systems without any issues. It's incredibly versatile. Now, having a tunnel is one thing, but you've got to make sure it's secure, right? Just building a road isn't enough. You need to add some serious armor to whatever is traveling on it. And here is an absolutely crucial point. L2TP is a master tunnel builder. It's fantastic at creating the pathway. But, and this is a big but, by itself, it doesn't actually scramble or encrypt the data that's flowing through it. It gives you privacy of passage, sure, but not secrecy of content. And for that, it needs a partner in crime. L2TP is almost always paired up with another protocol called IPsec. Think of it this way. If L2TP builds the tunnel, IPsec is the armored guard inside that tunnel, encrypting every single packet and making sure that even if someone could peek inside, all they'd see is gibberish. They are a true security power duo. So to even get into this super secure tunnel, you have to prove you belong there. And there are different levels of security for that. You might use a simple password. That's kind of like a hotel room key. For something stronger, you could use a digital certificate. Think of that as a high-level government security badge. And for the highest level of security, you've got multi-factor authentication, which is like a bank vault that needs multiple different keys to open. But of course, even the best laid plans can run into problems. If your connection fails, think of it like a traffic jam in the tunnel. Usually, the fix is just making sure you have the right server address. If you get an authentication error, well, that's like showing the wrong ID at a security checkpoint. You'll want to double-check your username, password, or certificate. And if things just feel slow,
It's often just digital road congestion, which you can sometimes ease by tweaking a few network settings.
All right, so we've gone through the blueprint, the real-world uses, and all the security. What's the big picture here? What's the one thing you should really take away from all this? The final takeaway is this: L2TP with a fundamental piece of our digital lives. It's the invisible engineering that creates trusted pathways, letting our private information travel safely across a very public and, let's face it, sometimes chaotic internet. It really is the tunnel through the mountain, the diplomatic pouch in the mail, and the private subway running under the city.
And that kind of leaves us with one final thought to chew on. Our data is becoming more and more valuable every single day, and our world is more connected than ever. So the need for these secure pathways is only going to grow. The real question isn't whether we'll need tunnels, but what kind of new, even better digital tunnels will we need to invent and build next?